Hello everyone, in this video we are going to discuss about the distance between 2 points in the two-dimensional plane from the chapter Orienting Yourself, the Use of Coordinates, Class 9 Mathematics, Ganitha Manjari, Part 1. See, according to the Pythagoras theorem, the distance between any 2 points P and Q is given by this equation. That is, if we consider 2 points P and Q such that the coordinates of P is x1, y1, x coordinate of P is x1, y coordinate of P is y1, and the coordinates of Q is x2, y2, that is x coordinate of Q is x2, y coordinate of Q is y2. If it is so, the distance between these 2 points P and Q, that will be equal to PQ equals square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. That is, in this system, here I have just considered one x-axis and y-axis, and I consider 2 points P and Q here. Okay, see, the x coordinate of P is 1, y coordinate of P is 2. Okay, similarly x coordinate of Q is 5, y coordinate of Q is 4. Okay, so 1, 2 is the coordinates of this point P and 5, 4 is the coordinates of this point Q. If you want to find out the distance between these 2 points, distance between these 2 points means we want to find out this distance PQ. Okay, this distance PQ is given by this equation, that is square root of x2 minus x1 the whole square. So x2 means x component of Q, that is 5, minus x1 is the x component of the point P, which is 1. So 5 minus 1 whole square plus y2 minus y1 all square. See, y2 is the y component of the point Q, which is 4. So 4 minus y1 is the y component of this point P, that is 2. So 4 minus 2 all square. So this becomes PQ equals square root of 5 minus 1 is 4. So 4 square plus 4 minus 2 is 2. So 2 square. Okay, that is PQ will be equal to square root of 4 square is 16 plus 2 square is 4, that is square root of 20. Okay, so square root of 20 units, if it is in meters, then square root of 20 meter, that will be the distance between these 2 points P and Q. Okay, so in general, if we consider the coordinates of P as x1, y1 and coordinates of the second point Q as x2, y2, then the distance between these 2 points can be found out by using this Pythagoras theorem. That is, according to this, the distance between these 2 points P and Q is given by this equation, PQ equals square root of x2 minus x1 all square plus y2 minus y1 all square. Now, let us consider this figure which is given in your textbook. That is, one triangle ADM is given here. See this triangle, the coordinates of each point A, D and M of this triangle, that is also given here. The coordinates of A is 3, 4. Coordinates of D is 7, 1. Coordinates of M is 9, 6. Okay, and you see this triangle ADM, it is an acute angled triangle. It is said in your textbook that, it is given in your textbook that this triangle ADM is an acute angled triangle. That is, each angle will be less than 90 degree. So this triangle ADM is an acute angled triangle in the first quadrant. In the first quadrant, the x values will be positive and y values also will be positive. Okay, we want to find out the length of each side of this triangle. That is, we want to find out the length of this side, that is AD. We want to find out AD, and we want to find out the length of this side of the triangle, that is DM. And we want to find out the length of this side of the triangle, that is AM. Okay, so we want to find out AD, DM, AM, or you can write it as MA. Okay, we want to find out AM or MA. Okay, so how do we find the length of each side of this triangle? Let us see. So, to get the length of each side of this triangle, I am going to use the Bodhayana-Pythagoras theorem which we have just discussed. That is, if we have 2 points P and Q such that the coordinates of P is x1, y1 and coordinates of the point Q is x2, y2, then the distance between these 2 points will be given by this equation PQ equals square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Okay, so if we use this theorem here, we can write, we want to find out the length of this side of the triangle, that is AD. So AD will be equal to square root of x2 minus x1. So 7 minus 3 is 4. So 4 square plus y2 minus y1. That is 1 minus 4. Right. We are finding out the length of this triangle. The length of the side of this triangle. That is, we want to find out this length AD. So the equation is x2 minus x1. That is 7 minus 3 which is 4. So 4 square plus y2 minus y1. y2 is 1. 1 minus 4. 1 minus 4 is minus 3. So minus 3 all square. Okay, so when we do this, we will get square root of 4 square plus minus 3 all square. So minus square is actually plus. So plus 3 square. Okay, now AD equals square root of 4 square 16 plus 3 square 9. That is square root of 25 which is 5. So we can write the length of this side AD as 5 units. If the unit is mentioned like centimeter, meter, you can write here 5 centimeter, 5 meter like that. Since no units are mentioned here, we are just writing it as 5 units. Similarly, next let us just find out the length of this side of the triangle, that is DM. Okay, so to find out this DM, we can write DM is equal to square root of x2 minus x1. So 7 minus 9. Okay, 7 minus 9. 7 minus 9 is minus 2. So minus 2 all square plus y2 minus y1. So 1 minus 6. 1 minus 6 is minus 5. So minus 5 all square. Okay, that is, this becomes square root of minus square is plus. So plus 2 square plus, when we take the square of minus, it becomes plus. So 5 square. That is square root of 4 plus 5 square is 25. That is DM equals square root of 29 units. Okay. Now let us find out the length of this side of the triangle. That is, we are going to find out this length MA. So MA will be equal to square root of x2 minus x1 the whole square. That is 9 minus 3. X component of M is 9. X component of A is 3. So x2 minus x1 means 9 minus 3. 9 minus 3 is 6. So 6 square plus y2 minus y1 all square. y2 means y component of M. y1 means y component of A. So y2 minus y1 means 6 minus 4. 6 minus 4 is 2. So 2 square. Okay, so MA equals square root of 6 square is 36. 2 square 4. So this will be equal to square root of 40 units. Okay. Now, in your textbook, in figure 1.9, this triangle AMD, it is actually reflected in the y-axis. The figure is there in your textbook. And the question is, what are the coordinates of the images of points A, M and D? See, triangle AMD is here in this quadrant. Now this triangle is reflected in the y-axis. Okay, and it is given as, you see, the image of this point A is given as A dash here. The image of this point M is given as M dash here. And the image of this point D is given as D dash here. Okay, now you see, The coordinates of A is 3, 4, x coordinate is 3, y coordinate is 4. For this point D, x coordinate is 7, y coordinate is 1, so 7, 1. For this point M, see x coordinate is 9, y coordinate is 6, so the coordinates is written as 9, 6. Similarly, if we consider this image of this triangle which is reflected in the y-axis, the image of A is taken as A dash, where the x coordinate of A dash is minus 3, y coordinate is 4. That is why the coordinates is written as minus 3, 4. The x coordinate of D dash is minus 7, y coordinate is 1. So coordinates of D dash is taken as minus 7, 1. Similarly, x coordinate of M dash is minus 9 and y coordinate is 6. That is why the coordinates of this point M dash is taken as minus 9, 6. Okay, now if you want to find out, so you see the coordinates are here. Now, suppose we want to find out the length of each side of this triangle. So, if you want to find out the length of this side, that is D dash M dash. So, we can write D dash M dash equals, we have the equation from the Bodayana-Pythagoras theorem, that is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square, right? So you see here x2 minus x1, so y coordinate of M dash is minus 9, so minus 9, sorry, x coordinate of M dash is minus 9, so minus 9 minus x coordinate of D dash is minus 7, so minus 7 x2 minus x1 the whole square plus y2 minus y1 the whole square. So y coordinate of M dash is 6 and y coordinate of D dash is 1. So 6 minus 1 all square. That is, this is equal to square root of minus 9. Minus into minus becomes plus. So plus 7 all square plus 6 minus 1 all square. That is, this can be written as square root of minus 9 plus 7 is minus 2. So minus 2 all square plus 6 minus 1 is 5, so 5 square. That is, this will be equal to square root of minus 2 all square. Minus 2 all square means minus square is plus, so plus 2 square, that is 4, plus 5 square is 25. So when we do this, we get D dash M dash equals square root of 29 units. Similarly, if we find out the length of this side, that is M dash A dash, we can write M dash A dash equals, so this is equal to square root of, see x component M dash A dash now, so x component of A dash is minus 3, x component of M dash is minus 9, so minus 3, I'm taking, see, when we apply this Bodayana-Pythagoras theorem, the equation is like square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. This can also be taken as square root of x1 minus x2 the whole square plus y1 minus y2 the whole square, no problem. That is, you just want to take the, the difference of the x component, then take the square of it, plus the difference of the y components, then take the square of it. Okay, it doesn't matter whether you are writing x2 minus x1 or x1 minus x2. Similarly, y2 minus y1 or y1 minus y2. Okay, so you see here when we find out M dash A dash, the x component of A dash is minus 3. So minus 3 minus x component of M dash is minus 9. So minus 9 x2 minus x1 the whole square plus y component of A dash is 4, so 4 minus y component of M dash is 6, so 6 all square, so y2 minus y1 the whole square. So this will be equal to square root of minus 3, minus into minus becomes plus, so plus 9 all square plus 4 minus 6, 4 minus 6 is minus 2, so minus 2 all square. So this will be equal to square root of minus 3 plus 9 is plus 6, so 6 square plus minus 2 all square is minus square is plus, so 2 square. Okay, so we can write m dash a dash equals square root of 6 square is 36, 4 square that is 2 square that is 4. So we will get it as square root of 40 units. Okay, similarly you can find out the length of see this side d dash a dash by using the same theorem. Now in your textbook page number 11, there is one in-text question which is given as think and reflect. That is, this figure is actually given there. According to the figure given here, we want to answer the questions. That is, the first question given in your textbook is, what has remained the same and what has changed with this reflection? That is, here we have the y reflection of this triangle. That is, here we have a triangle AMD. This is in the first quadrant. Or that is, we have the triangle AMD in the first quadrant. Now this triangle is actually reflected in the y-axis and shown here. The question is, what has remained the same and what has changed with this reflection? So here you see, in this reflection about the y-axis, you see y coordinates of all points remain the same. Right. See, y coordinate of this point A is 4. In the reflection also y coordinate is 4. Here it is 6. In the reflection also it is 6. Here it is y coordinate is 1. In the reflection also it is 1. So in this reflection about the y-axis, the y coordinates of all points remain the same. Now what about the x coordinates? X coordinate of this A is 3. But in the reflection about the y-axis, the x coordinate is minus 3. Similarly, x coordinate of this point D is 7. But in the reflection, x coordinate is minus 7. X coordinate of this point M is 9. But in the reflection, x coordinate is minus 9. That is, the x coordinates change their signs. Okay, positive becomes negative and negative becomes positive in these cases. So you see, in this reflection about the y-axis, the y coordinates of all the points remain the same, while the x coordinates change their signs. Now, there is one more question. Would these observations be the same if triangle ADM is reflected in the y-axis? Here this triangle is reflected in the x-axis or about the x-axis. Sorry, in this case, this triangle is actually reflected in the y-axis, that is about the y-axis. So instead of the y-axis, if this triangle was reflected in the x-axis, would these observations be the same? That is the question. No, the observations would not be exactly the same, because when we take the reflection about the x-axis, the x coordinates will remain the same. Okay, that is, when we take the reflection of this triangle about the x-axis, the x coordinates of each point will remain the same. That is, it will be 3 here, 7 here, 9 here, like that. But the y coordinates will change their signs. That is, y coordinate of A becomes minus 4, y coordinate of D becomes minus 1, and y coordinate of this M becomes minus 6. Okay. So in this video, we have discussed about the Bothaina-Pythagoras theorem, that is how to find out the distance between two points if their coordinates are given to us. And also we have discussed about the think and reflect question, which is an in-text question given in your textbook. I hope it is clear to you. Thank you.